In this video, we will be discussing the fourth part of the Terraform series, where we will be creating a VPC with a subnet security group and EC2 instance. We will create an Amazon virtual private cloud with a subnet, internet gateway, and custom route table using Terraform. We will then create an elastic network interface and associate an elastic IP address with it. We will also create a security group to allow ports 22, 80, and 443. Finally, we will create an EC2 instance and install Apache on it. By the end of this video, you will have solid understanding of creating a VPC with subnet, security group, and EC2 instance using Terraform. I am a full stack developer and a top rated plus freelancer at Upwork.com. Also, if you have not subscribed my channel, you can subscribe now. It helps to create more courses and tutorials for free. So let's get started. Let's begin by discussing the project outline. First of all, we will create a VPC, then we will create internet gateway. At the third, we will create custom route table. At fourth, we will create a subnet. At 5, we will associate subnet with route table. At number 6, we will create security group to allow ports 22, 80, and 443. At number 7, we will assign ENI with IP. At number 8, we will assign elastic IP to ENI. At number 9, we will create IAM Role to access S3. At number 10, we will create Linux server and install and enable Apache on it. At the end, at point 11, we will enable VCP Endpoint. Before we start creating the infrastructure, we need to set up the environment. We will be using the AWS provider for Terraform to create the infrastructure in AWS. The first step is to create the directory and initialize it with Terraform. So let's get started. First of all, you have to create a folder and you can open the folder in Visual Studio Code. Okay, and then you have to create a file main.tf. Okay, this is our Terraform file where we will write our Terraform code. Okay, and then we have to define our provider, as we are going to use AWS provider. Okay, so we will define our provider first. Okay, and the region we are going to use for our configurations. Okay, so we are going to use US East 1 in this video. Alright, so this code configures the AWS provider for Terraform and sets the region to US East 1. So now let's move to the point 1, which is creating a VPC. Let's define a resource. The resource name will be AWS VPC. Okay, and here we need to define CIDR blog. And we need to assign an IP. And then we have to define tags to assign a name CodeWithMuh. Alright, so this is our resource of VPC. Alright, no, it's fine. So here we created a VPC with CID or block, and we also added a tag with the name CodeWithMuh to identify the VPC. Alright, so next we need to create internet gateway. For this, I will just write creating an internet gateway. Okay, let me create some space for this option 2. Okay, here we are going to create an internet gateway to allow our VPC to communicate with internet. We will use the AWS internet gateway resource for this. Okay, so let's create a resource here, AWS internet gateway GW CodeWithMuh. You can also give any other name as well. Alright, so let's define some properties here. VPC ID we have to give. Okay, AWS VPC .a.id. okay, so because we are using the VPC we have created earlier, okay, so I have given the name we have created earlier. Okay, so this is our internet gateway. So here we need to assign a name. Okay, for this we can add a tag here. Okay, and we can assign a name to this internet gateway. I can give a name internet gateway CodeWithMuh. Okay, so this is our internet gateway resource. Okay, so we have just created an internet gateway and associated with a VPC we created earlier. We also added a tag to identify the internet gateway. After creating the VPC and internet gateway, we can create a custom route table to specify how traffic should be routed between the VPC and internet. In this case, we want to route all internet bound traffic through the internet gateway we just created. To create a custom route table in Terraform, we use the AWS route table resource. We specify the VPC ID using VPC ID attribute, and then we define a default route to define internet gateway using route block. So let's create resource for our AWS route table. So this will be our number 3 resource we are going to create here, which is to create a route table. Here we need to create a resource, and resource name will be route table and name resource table CodeWithMuh. Alright, no, here we need to define some attributes. VPC ID, which we have already created. I will just give name AWS VPC.a.id. okay, next we need to assign a route. Okay, for this just create a route here, CID or block, so we can write an IP address so it can access. Alright, so make sure your syntax is correct. Next we have to define gateway ID as well. AWS internet gateway dot gateway name CodeWithMuh. All right, so we have now assigned two things in our route, CIDR block, okay, and we have also defined gateway ID as well. Okay, so we are now done with our route. Next we need to create another route as well, and here we can assign IPv6 block, and we can assign here. Alright, next we have to assign gateway ID AWS Internet Gateway .tw CodeWithMuh, the name of internet gateway we created earlier, CodeWithMuh.id. Okay, so we have created two routes here. Okay, make sure we don't need to add quotations here. Okay, all right, so next we have to add tag, so we can give name to our route table. Okay, so the name will be for our route table. I can give name tags, we can add tag to give name. Okay, so it will be route table CodeWithMuh. Alright, so now we have defined our route table as well. Okay, so now we are done with our route table. Here we have just created a AWS route table resource and named it route table CodeWithMuh. We set the VPC ID attribute to the ID of the VPC we created earlier using AWS VPC ID. Next, we defined a route to the internet gateway using route block. We specify a CIDR block of 0.0.0, okay, so which matches all IP addresses, and set the gateway ID attribute to the ID of internet gateway we created earlier using AWS Internet Gateway. Finally, we added a tag block to resource to give it a descriptive name. Okay, so next we need to move to our resource number 4. Okay, we are going to create a subnet. Creating a subnet. Know that we have a VPC and a route table. We can create a subnet for our resources. In this case, we want to create a subnet in the US East 1A availability zone with a CIDR block. Okay, to create subnet in Terraform, we use AWS subnet resource. Okay, we specify the VPC ID using VPC ID attribute, the CIDR block using CIDR block attribute, and the availability zone using the availability zone using the availability zone attributes. Now let's define our resource. Okay, so we can create a subnet here. For this, we can just create a resource AWS subnet and name subnet CodeWithMuh. Okay, so here we need to first check VPC ID. VPC ID, we have already AWS VPC dot a dot ID. Okay, and next we have to create another attribute which is CIDR block, and here we need to assign an IP. Okay, so next we have to define availability zone. We are going to use US East 1A. Okay, then we have to add another attribute which is depends on AWS Internet Gateway dot gateway name CodeWithMuh. Okay, next we have to add a tag subnet CodeWithMuh. So this is our resource number 4 where we have created a subnet. We set the VPC ID attribute to the ID of the VPC we created earlier using AWS VPC ID and the CIDR block attribute to this IP address and the availability zone attribute to US East 1A. We also set the depends on attribute to the internet gateway resource to ensure that the subnet is created after the internet gateway. Finally, we added a tag block to resource to give it a descriptive name. Next, we are going to create. Next, we have to associate subnet with route table. So this will be our number 5 resource. So this will be our number 5 resource. Associate subnet with route table. Give me a space. Okay, so let's define the resource. To associate the subnet with route table, we will use the AWS route table association resource. In the code, we have already created subnet and route table. We will just use their IDs to create the association. Okay, and then following. Okay, now let's write down the resource here. Okay, and resource will be AWS route table association and the name RT2 subnet. We need to make sure the names are correct. Okay, next we have to write some attributes. Subnet ID we have already created, which is AWS subnet dot subnet CodeWithMuh dot ID. We have already created the subnet, so we are using the same ID we have created earlier in this code. Okay, so next we have to define another attribute which is route table ID. And here what we need to do, AWS route table dot RT CodeWithMuh. Okay, so now we have assigned the ID of a route table as well. So here we created a new resource called AWS route table association, and we assign the subnet ID and route table ID to the route table ID. Okay, and this will create association between subnet and the route table. Okay, so now we are done with our resource number 5. Next we have a resource number 6. We will create a security group to allow ports 22, 80 and 443. Okay, so here we need to create this security group. Let's define the resource here. AWS security group. All right, and a name we can give short name SG CodeWithMuh. Okay, so then we have to give a name here, SG CodeWithMuh. Next we have to assign a description as well. We can write anything, allow SSH, HTTP, HTTPS, okay, inbound traffic, because 22 will be used for SSH, 80 will be used for HTTP, and 443 will be used for HTTPS. Okay, so next we have to assign VPC ID. We have already created AWS VPC dot a dot ID. Okay, next we need to define some ingress. Okay, so let's write first ingress description, HTTPS from VPC. Okay, and here we need to define from port 443, okay, to port 443. Okay, and next we have to create another attribute which is protocol TCP. Okay, then we have to assign another attribute CIDR block. It will be CIDR blocks. All right, okay, and we have to here write the IP 0.0.0. okay, so this is our first ingress we have defined. So here next we have to define for HTTP and also for the SSH as well. Okay, so what I can do here, I can just copy this one and paste below. Okay, I can use HTTP here and the port 80. Okay, we need to remove 4 here. Okay, no, it's fine. And here we need to also write port 80. Okay, this is also TCP. Okay, fine. Okay, next we need to just copy it again. Okay, and we need to just paste it. Okay, and then we have to define SSH from VPC. Okay, this is for the port 22. Okay, got it. Okay, so now we have defined all these 3 ingress for inbound traffic. Okay, at the end we have to define another which is egress. Okay, from port 0, okay, to port protocol. It will be -1 CIDR blocks. Okay, now here we need to just make sure to add the IP. Alright, so our egress is also ready. Next we need to just assign a tag to our security group, okay, which will be name SG CodeWithMuh. Alright, so this is our security group we have created here. If I can show you here, you can see this is our security group we have created. Okay, so here we are using AWS security group resource to create a security group named SG CodeWithMuh. We are providing the name prefix for the security group along with the VPC ID of the VPC we created earlier. Okay. Then we are also defining ingress rules to allow traffic on ports 22 for SSH. Okay, for port 443 for HTTPS and for port 80 for HTTP. Okay, and also we have defined egress rules to allow all outbound traffic as well. Okay, finally we have added a tag to the security group for easy identification. Okay, alright, so now we are done with our resource number 6. Next we are going to create resource number 7. We are going to assign ENI with IP. We are going to assign Elastic Network Interface with IP. Okay, so let's create a resource AWS Network Interface ENI A. Okay, so this will be the name. Next we have to assign subnet ID AWS subnet dot subnet CodeWithMuh dot ID. Okay, so we have already created this subnet, so we are using the same subnet here. Next we need to define another attribute which is private IPs. We can define here 10.00, okay, and add then 10. Okay, no, it's fine. Next we have to assign security groups. AWS security group dot SG, the name of security group we have created earlier, CodeWithMuh dot ID. Okay, so here we have created a ENI Elastic Network Interface with a specified private IP address in the subnet identified by the resource AWS subnet CodeWithMuh. Okay, then we have associated the Elastic Network Interface with the security group. Okay, so now we are done with our resource number 7. Next we have to create resource number 8. Here we are going to assign Elastic IP to the Elastic Interface Network. we are going to assign elastic IP to the elastic network interface. Assign elastic IP to ENI. Let's define resource AWS elastic IP, and the name elastic IP, I will give name A. Here we need to define first attribute VPC, okay, which is equal to true, okay. Next we have to define network interface, which will be AWS network interface, okay. Here we need to assign internet network interface we have already created, okay. So I have assigned the ID, okay. Next we have to create association with private IP attribute, association with private IP, okay. We can just assign 10.0.10, okay. Next we have to create another attribute depends on. Here we need to add AWS internet gateway dot sg, the name of internet gateway, okay. So it is GW CodeWithMuh, okay, and the ID, okay. Next we have to also assign AWS instance dot the instance name, okay. So here we have just created few attributes in this resource, okay. Next we have to create tag, okay. So we can give name to our elastic IP. I will just give name tags name elastic IP, okay, done. So what we did here in this resource, we have created an elastic IP address and associated with the ENI identified by the resource AWS network interface. Then we have associates the elastic IP address with the private IP address, okay, on this ENI. Then we have specified the elastic IP address, okay, which is associated with the VPC. Also we have added a tag, okay, for this elastic IP address with the name EIPA, okay. And also we have added depends on attributes, okay, with AWS instance and internet gateway, okay. So now we are done with our elastic IP resource number 8, okay. Next we are going to our resource number 9. We are going to create IAM role to access S3, okay. So this is our resource number 9. For this role, okay, you have to just copy a code because this role is little bit lengthy, okay. So we can save time here, okay. So I will just copy and paste the IAM role resource here, okay, and I will explain you. Okay, so now I have added a resource, okay. Here you can see this is all the code of our resource number 9, okay. So what I have did here, let me explain you, okay. First of all, we have created an IAM role named EC2 S3, okay, with the trust policy that allow EC2 instance to assume that role, okay. And we have created an instance profile named EC2 S3 profile, okay, and associate it with the IAM role created by resource AWS IAM role EC2 S3, okay. and then we have created an IAM policy named test policy and associated with the IAM role created by the resource IAM role EC2 S3. Okay, and then we have grant some permission to perform all the action, okay, on S3. Okay, so using this syntax. Okay, so now we are done with our role. So now we are done with our resource number 9. Okay, now let's move to our resource number 10. In resource number 10, we are going to use to create an Linux server, and we will install and enable Apache 2. When our EC2 will be launched, automatically Apache will be enabled on our Linux instance. Okay, so we need to create Linux server and install enable Apache 2. Okay, so what I can do here, I can also just copy and paste the code I have already written. Okay, so you can then just copy it. Okay, so this is our resource AWS instance. Here we are creating an EC2 instance using Amazon Linux AMI. Okay, and we have set the instance type to the T2 micro, and then we have specifies the availability zone to launch the instance in US East 1A. Okay, then we have specifies the key pair to use for SSH access. I have given name CodeWithMuh. Okay, we will create this key pair before we apply the changes. Okay, then we have created an IAM instance profile. Okay, and then we have specified the IAM instance profile created in our resource 9. Okay, then we have associates the instance with the network interface created in resource 7. Okay, then we have defined some user data script to install and enable Apache and start the Apache server and sync the contents of S3 bucket to the Apache document root directory. Okay, and then at the end we have just define a tag for instance with the name CodeWithMuh 1.0. Okay, so this was our resource number 10. So now we have last resource, which is resource number 11. Resource number 11, okay, which is our last one resource, enable VPC endpoint. Okay, so here we can define resource AWS VPC endpoint S3, and we need to just define some attributes here: VPC ID, AWS VPC .a.id. We have already created this VPC. Okay, so I have just defined the attribute VPC ID. Then we have to assign another attribute which is service name. Okay, and here we can define com.amazon aws.us east 1.s3. Okay, so this is our service name we have defined here. Okay, next we have to just write down the tags to assign a name. Okay, test, I will just give name to this, a test. Okay, so all right, now we are done with our all the resources. Okay, now let me just explain this last resource. Here we have created an S3 VPC endpoint in the VPC created in the resource number 2. Then we have specified the service name for the S3 endpoint, okay, with this name. Okay, and then we have just set a tag for the endpoint with the name test. Okay, so these are all our resources. Okay, so what we have to do now here, we need to just confirm that our code is correct, we have any mistake or not, all things are correct. So we can just double check here. Okay, so first of all we have created AWS, okay, as a provider. Then we have created a VPC, okay, this is also fine. And then we have created an internet gateway, okay, so this is fine. Next we have created a route table, okay, which is also looks fine. And at the end we have created a subnet resource, okay. And then we have just created resource number 6, which is a security group, okay. And here we need and here we did a mistake. Here we need to just make sure our syntax is correct, okay. We need to assign this operator, okay. All right, okay. So it is a good practice to confirm everything is fine, okay. So all other resources are fine, okay. So now we are just done. What we have to just open our terminal now, okay. We have to just to move to our folder, okay. My folder name is part 4. I will just move to this folder 04, okay. So here we need to just first of all do initialization, okay. So before we apply infrastructure, we need to create a key pair, okay, which we have defined in our point number 10, okay. If you look into this, for example, if I go into the point number 10, you can see we have a key pair named CodeWithMuh, but we have not created this key pair in our AWS account. First of all, we need to just create this. So for this we have to run a command so we can create our key pair. For this you have to just run command AWS EC2 create key pair key name okay. So here we need to define our key name. So we have already written the key name CodeWithMuh. So what I will do here, I will just keep the same name here. For example, if you go above, okay, our key name is CodeWithMuh, okay. So C is capital, so I will just write it again, CodeWithMuh, okay. So make sure your key name is correct, okay. So CodeWithMuh and query. Next we have to here key material, okay. And then we have output text, and then we have to again write our key pair name CodeWithMuh.pim. So in this format the file will be downloaded. So actually this is the command which will create key pair, okay, with the name CodeWithMuh, okay. So this query will be applied and our key pair will be downloaded, okay. So just double check your syntax is correct, okay. So what I will do here, I will just hit enter, so our key pair will be downloaded, okay. So just let me just hit enter, so you will see the key pair is downloaded here, okay. It's a good practice to do and create key pair in this way. Alright, so we are done with our key pair. Okay, next we have to just initialize our Terraform project, okay. What I will do here, I will just write Terraform init, okay. So it will create some necessary folders, file structure, okay, plugins. So our Terraform project will be initialized. Okay, so our initialization is done. Okay, next we have to just validate that our code, everything is fine or not. For this, we can just run command terraform validate, okay. So it will give us, okay, you can see here we did some mistakes, okay. So it will tells us where we have issues in our code, okay. It's a best practice to do terraform validate, okay. So it will tells if we have some mistakes in our code lines, okay, so we can fix before applying, okay. So here you can see at line number 41, line number 1 to 4, and line number 2 to 4 we have some mistakes. Then how we can fix these mistakes? We have to just first go to the line number 41. We have issue all the in our tags line, okay. So let's fix these issues now. If I just go to line number 41 first, okay, this is our line number 41. So you can see we have forget to add equal sign, okay. Next we have the issue in our line number 124, okay. We have reference to undeclared resource, okay. If we go to this line number 124, okay, and also on the line number 220 we have also the same issue. We can fix the issue first, this one. First of all, line number 220, okay, yeah, here you can see. So we can just fix it. So it's a good practice to validate resources if any issue happened in your code. Okay, so we have no last issue we need to fix at line number 1 to 4. So we have to just open line number 1 to 4. Okay, so here we are getting an issue. So we need to first check where is the issue, okay. If you check, we have the mistake here, network, okay, the spells are not correct, okay. So no, it's fine. So now we have fixed all these issues. Now let's validate it again. So we will see if any success message, it's mean our code is fine. Okay, still we have the issues on line number 125 and 128. Now let's move to the line number 125 and 128, okay. Here we need to add tags as well, okay. And line number 125, okay. If we just move to line number 125, we can see here we have a mistake, association with private IP. Okay, so we have issue here. We need to just make sure our attribute name is correct. Actually the name is associate, okay, not association, okay. So associate with private IP, okay. So now we have also fixed these two bugs as well. Now let's me validate it again. Okay, now you can see our code is fine and we have received the success message, okay. So and that's why I have made some mistake to show you how to validate your code before making any changes and applying, okay. So next we have to run command terraform plan. So this command will tells us which things you are going to create on your AWS, okay. So it's a good practice to run the command to see which things we are going to add, okay. 13 things we are going to add, okay, all the security group and everything, okay. You can see the list is provided here, okay. So what is going to be created in our AWS, okay. So all is fine. Now let's apply changes. What I will do here, terraform apply, okay, the syntax is not correct, terraform, okay, apply. So it will ask us to give permission to create resources on AWS, yes. So it will create resources on the AWS, okay, like EC2, S3, all the resources. So all the resources are being created. When all the resources will be created, we will just open our AWS to verify the resources are created or not. Okay, this is my AWS account. I will just go to EC2. We can check if our EC2 is created or not. You can see our EC2 instance is being initialized. Okay, so this is our EC2 instance we have created in our point number 10. Also you can see all the resources are created, which is a great thing. Okay, and also if you can see here at point number 10 we have the Linux server, which is CodeWithMuh. Okay, so this instance is also created. Okay, because the name of our instance name is CodeWithMuh 1.0. so if you just edit it, you can see the correct name. Okay, so similar all the resources are also created. Also if you check the security group, we have given name the security group SC CodeWithMuh, it is also created. Okay, so it's very easy to create resources and create infrastructure. Okay, using AWS. Okay, so what we have to do here, because it was a testing purpose. Okay, if you are also doing it for testing purpose, you can delete all the resources. Okay, because otherwise it will charge you extra. Okay, I will just delete Terraform destroy. Okay, so it will destroy my all resources that I have created on AWS. Okay, all the list of resources which are going to be deleted are being listed. Okay, so we give need to permission, yes, so all the resources will be deleted. So in this part of our Terraform series, we have successfully created a VPC and configured various resources within it using the Terraform infrastructure as a core tool. The resources created include an internet gateway, a custom route table, a subnet, a security group to allow inbound traffic on ports 2280 and 443, an elastic network interface with a private IP address, an elastic IP associated with ENI, and an IAM role for accessing Amazon S3. Additionally, we have installed and enabled Apache on a Linux server and enabled a VPC endpoint. The use of Terraform enables us to automate the deployment and management of infrastructure resources, allowing us to provision resources quickly and efficiently. The project provides an excellent example of how Terraform can be used to build, manage, and update infrastructure resources in an organized and scalable way. Alright, so this was all about of our project. Don't forget to like, share, and subscribe my YouTube channel. If you have any questions or feedback, leave a comment below. I will get back to you. Stay tuned for more courses and tutorials. And until next time, goodbye.